Hi, Assalamualaikum and a very good afternoon. So today we will have EBP418 Plastic Laboratory, and today I will briefly introduce to you Experiment 3, which is studies on extrusion technique. Right? So before we start, let's take a look, or let's have a recap about extrusion processing. Okay, so what is extrusion processing? Okay, so extrusion processing is a process that use an extruder, okay, to melt or to mix your polymer to get a product. Okay, so in the figure it shows you the extruder. So it consists of different some components, important components such as hopper, barrel, screw, heaters, nozzle, and also your extruded polymer. So what happened here is that you can put your polymer pellets in the hopper where it travels into the barrel. So inside the barrel it consists of a screw. Okay, it can be a single screw or it can be a twin screw. Okay, so these screws are used to mix your polymer in the barrel. Okay, so another factors that are needed to mix your polymer is of course the temperature. So in the barrel it has many heaters. Okay, it can have many heaters along the horizontal screw inside the barrel. So you can set different parameters at different region for a better mixing of your polymer. So at the end of the nozzle there is a die. Okay, we call it a die, where the die is used to form the shape of your finished product. So we call that an extruded polymer, where it came out from the die at the nozzle. Okay, so after that your polymer, the extruded polymer, will be fed into a conveyor belt for cooling. Okay, so you can have two options for cooling. The first one is you can cool your polymer by air, or you can cool your polymer by water. Right? Okay, so there are 5 important process parameters that to be considered in this experiment, in extrusion. Okay, so the first one is melting temperature, screw speed, extrusion pressure, types of die used, and also cooling medium. But today in this experiment we will consider 2 parameters. The first one is screw speed and the second one is the cooling medium. Right, so why are the process parameters are very important? Okay, for example, melting point. Why is melting point so important in extrusion? Okay, so typically for any product, okay, so any polymer, you always want a uniform melting. Okay, you know, so I think at this stage you already know what happened if you didn't have a uniform melting. So the product will have many defects. Okay, so for example, overheating of a plastic can cause degradation, which will reduce the performance of your material. Or you also don't want uneven temperature, where uneven temperature can give you unwanted stress that can cause defect, just such as warping. So that's why melting point is very important in extrusion processing. Okay, so now today we will take a look about the effect of screw speed. So in your extrusion you can set your screw speed at different rotation per minute, or RPM. You can start from 10 until 100. Okay, so you need to ask the question yourself, what is the importance of screw speed? Why different screw speed will give you different product or different observation of the quality of your product. Okay, so question to ask yourself, what is the function of the screw and how it helps to melt the polymer? Okay, what are the effect of using low screw speed and high screw speed? So is it the high screw speed is always better, or a low screw speed is better? So this is the question, okay, that we will observe in this experiment. Okay, and the second thing is cooling medium. So why cooling medium is important? Okay, in the figure you can see that in industry there are many industry they use different cooling medium. Some industry use water cooling and some industry use air cooling. So the question that you need to ask yourself is, what is the function of cooling medium and how it helps to freeze the extruded? what is the differences of using water and air medium as cooling, and which one is better. Alright, so this is the things that you will take a look in this experiment. Okay, let's go into the hypothesis. Okay, this is what you may observe if you are using different screw speed. Okay, so as a hypothesis, high speed, okay, can reduce the thickness of your polymer. So that's why you need an optimum. Okay, you need to know what types of product you want, so you need to adjust this. What you want is always optimum speed. So it doesn't mean that high speed is better. You need to measure yourself the optimum speed that can produce the high performance of your product. Okay, for example, if the screws are too slow, it could result in poor melt quality. Okay, or sometimes it can give you degradation because the material are in the barrel quite a long time because you are using a slow screw speed, so it might give you some degradation. So that's why you need to use an optimum speed. Okay, and these are the hypotheses is you are using different cooling medium. So you know that polymer, it need times to rearrange themselves into the final product. Okay, so proper part cooling is very critical for polymer to realign themselves. Okay, so it depends on the types of the polymer itself. If it is a semi-crystalline polymer, so the temperature needs to be below melting point to freeze the final part product. Or if you are using a amorphous polymer, if you are cooling the amorphous polymer, the temperature needs to be below the TG to freeze the final part of your product. So that's why for your cooling medium also you need to know the optimum, which one is much better for you, and of course it depends on your types of polymer as well. Alright, so how you can observe the effect of screw speed and effect of different cooling medium. Alright, so one way to observe this, okay, using naked eye is by measuring the die swell. So the product, okay, that come out from the extruder is in a like a tube. So you when it go inside the barrel, okay, when it come out into the die, it was forced to follow the dimension of the die. So when it come out, it will swell, okay, because polymer needs time to realign, so they will swell. So this is the things that you can observe, okay, when you are using different effects such as screw speed and cooling medium. Okay, so die swell can vary from 10% to 100% in dimension. So in this case, you want to optimize your die, not optimize, you want to minimize your die swell. You don't want it to be bigger. Okay, why? Because for example, if you are making a pipe, okay, so if you are making a 3 centimeter pipe, if it come out from the extrusion and it swell into 5 centimeter, so you cannot use the pipe anymore because you want a 3 centimeter, but it came out to be 5 centimeter. Alright, so that's why die swell is very important, and the way you want to control is through screw speed and cooling medium. Alright, so in this experiment, okay, the objective is to study the effect of extrusion processing parameters on the melt flow and the quality of the extruding. Okay, so the material that you will use in this experiment is polypropylene or PP. The equipment is single screw extruder, image analyzer, stopwatch, vernier caliper, and also weighing scale. Okay, so the procedure is you will use different temperature, okay, from 90 degree to 150 degree at the extruder, and you will use 2 cooling medium. Okay, you will compare the cooling medium between air and also water. Okay, so in this experiment, please prepare your report according to the result that I've been given here. Okay, so this is the result for different screw speed. Okay, so in the table in part 1, you can see that different screw speed will, if you put the same mass, okay, but you are using different screw speed, it will give you different in time. So the first thing that you need to do is I want you to calculate the mass flow rate of each sample and discuss how the screw speed affected the mean residence time. Okay, residence time means the time of the sample in the barrel. So for example, if you are using a low screw speed, means that the polymer have more time in the barrel. Okay, but if you're using higher speed, it will come up faster if you compare to low screw speed. Okay, then you need to plot the graph of screw speed versus mass flow rate. So you need to discuss the trend and then explain why at the same feed material the mass flow rate is different. Okay, so this is the result for part 1. And this is the result for part 2. So after you discuss that, okay, so you need to calculate the volumetric flow rate. So you know the extruder is in a horizontal a pipe, so it has the product that come out from extrusion is always in a tube. Okay, so you need to consider the effect of volumetric flow rate. So you need to calculate the Q and also the Q actual. Okay, and you need to answer all the questions given here, right? And for the third part, or the effect of different cooling medium, okay, so I already given you the result for diameter or the die swell at different screw speed. So you need to plot the graph and also discuss the trend of your graph for different effect of different cooling medium. Right, so I think that's all for experiment 3. So you have 1 week to submit your report. Okay, thank you.